Now we move on to the second part of the wave equation problem. So we've already taken the equation itself and generated a set of families of possible solutions, one of which is a little bit further down the screen here, for k positive. Now what we do is we take the boundary conditions. So the boundary conditions are these two conditions here, and we just substitute them into our family of solutions. So here what we're saying is when x is 0, u will be 0. So if we try that, u0t equals 0. So when x is 0, what will we have? We will have u0t equals, both exponentials will be 1, so we'll have a plus b times ce to the kx, sorry, plus d e to the minus kct equals 0. So we have two alternatives. Either the second bracket is 0, and if that's the case, then that means that our whole solution is 0, so we discount that. So the only solution we've got which is non-trivial is that a plus b equals 0, or b equals minus a. Then we can take the other condition, u pi t equals 0, u pi t equals, using minus a instead of b now, we have a e to the k pi minus a e to the minus k pi times c e to the k ct plus d e to the minus kct. So again, second solution is 0, the second bracket is 0, or the first bracket is 0, so we must have a e to the k pi minus e to the minus k pi equals 0, but unfortunately that doesn't have any solutions. There are no values of k that we can put in there. Remember that in our case k is greater than 0. So for that whole family there are no solutions of that type. Brilliant. So that's something we can ignore. We go on to the next set of family of equations, and we have u, what was it, 0, I've got it wrong, no, 0t, that's right, equals 0. So you put x as 0 in there and you'll get u0t equals b times ct plus d. Either ct plus d is 0, we've got a trivial solution, or for non-trivial, b equals 0. Brilliant. Then we can do the pi t equals 0, so u pi t, knowing that b is 0, will give us a times pi times ct plus d, sorry, equals 0. So either the second equation is 0, gives us a trivial solution, or a equals 0. Oh dear, that means that there is the only solution in this case is the trivial one, where u is equal to 0 throughout. So no solutions of this type. Remember, this is for one particular set of boundary conditions, the fixed set. So we go on to the next ones. u0t equals 0. So we put x as 0 into this, and we'll get u0t equals cos of 0 is 1, so we'll get a. Sine of 0 is 0, so we'll just get a times c cos kct plus d sine kct equals 0. So either the second bracket is 0 or a is 0. So for a non-trivial solution, a is 0. Brilliant, that's getting rid of lots and lots of things. So up to now we haven't actually got any solutions to work with at all. Pi t equals, now if we put pi in here, remember that a is 0, we're going to get b sine k pi times c cos kct plus d sine kct equals 0. So either the second bracket is 0, that will give us a trivial solution, or b is 0, again a trivial solution. So the only thing that's left for non-trivial solutions is that sine k pi equals 0. Now, solutions for this are anything as long as k is equal to n. So solutions are k equals n, where n is 1, 2, 3, lots of them. Okay, so the only solution that we have to our equation is u xt, and here I'm going to put a little n on there because I get 1 for every value of these n's. Was it a was 0? So I'm going to have sine of nx, and k is equal to n, remember, so it would be c cos nct plus d sine nct. They're the only solutions that we have, and we have for every value of n we have a different one of these. Now if we look at the solution from the general equation from the notes, we showed that for fixed boundary, or for zero boundary conditions, that was the equation that you got, and that's exactly the same as what we've got here, because in our case L was equal to pi. So if you put pi in here, it'll cancel, and it'll cancel there, and it'll cancel there, and look what we have. We have sine of nx cn times cos of nct dn times, oh sorry, yeah, I should have a little subscript of n on both of those, because for every value of n we'll have a different value of c and of d. And that's the second part over with. Now we go on to look at fitting the initial conditions.